Hey everybody, Mr. Smith here. Let's jump in with a joke to start this video. What do you call an elephant that doesn't matter? You call that irrelevant. Maybe you saw that one coming, but I thought it was pretty funny. So let's talk about factoring now. We talked about factoring by grouping in our previous video. Today we are going to use that skill to help us factor a polynomial from scratch. Okay, so I wrote this little diagram right here for us to see and kind of remind you what factoring is exactly. We know how to multiply a polynomial. We could start from this and multiply it to get something that looks like this. Factoring is just reversing that process. We start with a polynomial that is all multiplied out. We factor it and undo that, and we end up with a couple different polynomials being multiplied together. So factoring is simply the process of taking one polynomial and writing it as multiple polynomials that are being multiplied together. That's what we're trying to accomplish with factoring. Okay. I have three examples that I'm going to walk us through. This video is meant to just be a little introduction to the process involved in factoring a polynomial. Before I start, just understand that factoring polynomials is a really important skill for us, not just in your math classes, but in many of your science classes moving forward. Factoring is going to be something that we come across a lot. That being said, the process that I'm about to show you may seem complicated and convoluted at first. And if you're confused immediately or you don't feel like you're a master right away, that's okay. Because just like lots of other things in life, this process and this skill may take a little bit of patience, it may take a little bit of practice, it may take a little bit of time for us to come around to mastery towards. And that's okay, all right? So I don't expect you to be a pro at this right away, and I don't think you should expect yourself to be a pro right away either. If this takes time, that's okay, all right? So I just want to preface with that. So let's look at this first example. I'm going to factor this polynomial. I'm going to take it and rewrite it as a couple different polynomials multiplied together. We're going to use a process that maybe other teachers might call it this too. It's a process that is called A times C add to B. If we think of our polynomial as being written like this, ax squared times bx plus c. These are all in standard form. The exponents are in decreasing order. I've just renamed the coefficients a, b, and c. This process that we're going to do is you can kind of map it out by saying a times c add to b. This means that the first thing I'm going to do is multiply a times c. So I'm going to take the first number and the last number, and I'm going to multiply those together. 4 times 3 gets me 12. Now I'm going to ask myself a question. This is the add to b part. I need two numbers that multiply to 12, this number that I got by multiplying first and last numbers. I need two numbers that multiply to 12 and add to b, which is 13. So I need two numbers that multiply to 12 and add to 13. This is typically the part of this process where people get hung up because we have a hard time figuring out what those numbers could be. So to make things a little bit easier, I would just go off to the side and write out all the numbers that multiply to 12, all the different factors of 12. Okay, so let's just think about that for a second. You could do 1 times 12, you could do 2 times 6, you could do 3 times 4. Those are all the factors of 12. Now I'm just going to ask myself, of these pairs, are there any of them that add to 13? Because I know that they all multiply to 12, but I also need them to add to 13. Well, 3 plus 4 is 7, so that doesn't work. 2 plus 6 is 8, that doesn't work. But 1 plus 12 is 13, which is exactly what I want. 1 and 12 multiply to 12, and they add to 13. That's exactly what I want. So now that I have my two numbers, what I'm going to do is I'm going to take the polynomial that I began with, 4x squared plus 13x plus 3, and I'm going to rewrite it, except instead of using 13x, I'm going to break that up into these two numbers, okay? So it's going to look like this. 4x squared plus 1x, I get the 1 from right here, plus 12x plus 3 at the end. That didn't change. Notice how 1x plus 12x is the same thing as 13x. I've just written it using these two numbers. Okay, so I haven't really changed anything. I've just rewritten this polynomial using these two numbers that I came up with. Now, this is in a position where I can factor by grouping, which is what we did in our last video. So now I'm going to factor this by grouping. I break it up into two halves. I'm going to look at the first half and ask myself, what's a GCF I could take out of that? I can't pull out any numbers, but I can pull out one x. So I'm going to factor an x out of that. It's going to leave me with 4x plus 1 on the inside there. The second half, again, what can I factor out of that? Well, 3 goes into both of these numbers. This doesn't have an x, so I can't factor out an x. So the biggest thing I can factor out is a 3. 12x divided by 3 is 4x, and 3 divided by 3 is 1. And notice, just like with factor by grouping, these are the same now, which is exactly what I want. So I can write my final answer as the repeated factor, 4x plus 1, times the two GCFs that I pulled out put together, x plus 3. And this is going to be my final answer. For sake of time, I'm not going to work us through it, but if you multiply this thing out, we would end up right where we started. Okay, so there's one example. Let's do another one. I'm going to do this one in a different color, so it's not as hard to follow. Okay, so again, I'm going to start the process here is the same thing for every single problem. Okay, we are always going to do a times c add to b. So I'm going to start by multiplying the first two numbers just like I did before. -4 and 5 gets me -20. I have to pay attention to the negative. Okay, so now I need two numbers that multiply to -20 and add to -8. So we might have to be careful here because these are both negative numbers. So when I'm thinking about numbers that multiply to -20, well, to get a negative number by multiplying, you need one number to be negative and one number to be positive. Okay, so let's just think about numbers that might multiply to -20. -1 and +20, -2, +10, sorry, -2, +10, got -4, +5. Those all multiply to -20. Let's just see if any of those add to -8. Remember, I need them to add to -8. -1 plus 20, that doesn't work. -4 plus 5, that does not work. -2 plus 10 gets me close. That gets me to +8. -2 plus 10 gets me +8, but I want -8. This gives me an idea, though, of what numbers I could use, because if I just switch these negative signs, +2 and -10, well, those also multiply to -20. And if I do 2 plus -10, well, that gets me -8, and that's exactly what I want, okay? So I'm going to go with 2 and -10 as my two numbers. Remember, it's helpful to just list out all your numbers that multiply to this until you come across a pair that adds to the number that you're looking for. All right, so now that I have my two numbers, I'm going to do what I did over here. I'm going to break this middle number up into these two numbers that I just chose. So it's going to be -4x squared plus 2x minus 10x plus 5. And now, similar to what I did over here, I'm going to factor by grouping. Notice how I include this negative sign in those parentheses. I'm going to take the negative sign with me. I can't just forget about it. All right, so now I'm going to look at this first polynomial, or this first half, and see if there's a GCF I can take out. I would recommend, if your first term is a negative sign, that's kind of a dead giveaway that you have to factor out a negative. So I see that 2 goes into both of these numbers, but since this is negative, I don't really like that. I don't like it being a negative. So to get rid of it, I'm going to factor a -2 out instead of a +2. That's going to make this a positive, okay? Both of these have an x, so I can also factor out an x. So -4x squared divided by -2x, that gives me +2x, which is exactly what I want, because now this thing isn't negative anymore, and I just don't have to think about that. 2x divided by -2x, I have to be careful here, that gives me a -1. 2x divided by -2x gives me a -1, so I got to be careful about that. Let's look at the other half. Well, I know that 5 goes into both of those things. I know I can't get an x out of there, but 5 goes into both of those. This is negative, so again, that's a dead giveaway that I'm going to factor out a negative 5. Negative 10x divided by negative 5, that's plus 2x. 5 divided by negative 5 is minus 1. And these are the same, which is exactly what I want. So my final answer is the repeated factor, 2x minus 1, times negative 2x minus 5, the two GCFs that I pulled out put together. And I'm done with that example. All right, let's do one more and that'll wrap up this video. In this example, the leading coefficient is just 1. I don't have a number in front, like in my previous two examples. The leading coefficient is just 1, which makes things a little bit easier. So again, I'm just going to start by multiplying the first two numbers. There is that imaginary 1 right there. So 1 times 12 is 12. And now I need two numbers that multiply to 12, add to negative 8. So let's just go figure out some factors of 12. But I need to be a little bit of a problem solver here because I need my two numbers to add to a negative 12. Okay. In order for that to happen, both of the numbers are going to have to be negative, most likely. And that makes sense because a negative times a negative gets me a positive. So I just need to use negative numbers here. Negative 1 times negative 12, that multiplies to positive 12. I can do negative 2, negative 6, and I can do negative 3 and negative 4. This is a 2. Okay, negative 1 plus negative 12 is not negative 8. Negative 3 plus negative 4 is not negative 8. But negative 2 plus negative 6 is negative 8. That's exactly what I want. Negative 2 times negative 6 is also positive 12. So you see how we kind of have to think on our feet a little bit, use some forethought, some critical thinking, and be a problem solver. Think, what am I trying to get to, and what steps am I going to need to take along the way to help me reach that goal? I know I need to add to a negative number, so I'm probably going to have to use two negative numbers to get there. Okay, so now that I've got my two numbers, I'm going to rewrite this polynomial, x squared minus 2x minus 6x plus 12. Again, I'm getting these two numbers from over here. And now I'm going to factor by grouping. And again, I include the negative sign in those parentheses. In this first half, I can't take out a number, but I can take out an x. X squared divided by x is just x. Negative 2x divided by x just gets rid of the x, so I have x minus 2. And now remember, whatever I factor out of this second piece, I want it to end up matching x minus 2. So that gives me an idea here. I need this to be positive because this is positive. So in order to get this thing to be positive so that it matches, I know I'm going to have to factor out a negative. Since 6 goes into both of these things, I know I'm factoring out a negative 6. That's going to turn this into a positive x. And then 12 divided by negative 6 gets me negative 2, which makes these match, which is exactly what I'm looking for. My final answer is going to be x minus 2, the repeated factor, times x minus 6, the two GCFs put together. And I'm done. All right, so hopefully these are clear examples. If you have questions, please reach out to me. If you need to go watch some other videos and just see some more examples of this, go for it. Like I said, this may take just a little bit of time, a little bit of practice, and a little bit of patience. That's okay. All right, you don't have to be a master right away. We'll take the time to make sure that we get good at this. All right, thanks, guys.